Word equations combine two skills that we have previously learned, naming and balancing equations. The first step is to write the correct formula. This involves changing the subscripts. When we are writing the correct formula, we need to remember to check for diatomic elements. Any Brinkelhoff element by itself should be diatomic. If we have an ionic compound, we have to remember to balance the charges. Again, both of these involve changing the subscripts. Once we have the correct formula, we can balance the equation. When we are balancing the equation, we can only change the coefficients. Let's look at some examples. In the first example, the word equation says hydrogen gas plus oxygen gas yields water gas. It is tempting to write the equation as H plus O goes to H2O. But we have to remember to check for diatomic elements. Both hydrogen and oxygen are diatomic when they're by themselves. So the correct formula should be H2 and O2. Now that we have the correct formulas, we can balance the equation using coefficients. Because there are two oxygen atoms in the reactants, we'll need two oxygen atoms in the products. We can get that by adding a coefficient 2 in front of the water. This gives us 4 hydrogen atoms in the products, so we will also need 4 hydrogen atoms in the reactants. We can get that by adding a coefficient 2 in front of the hydrogen. Now we have 4 hydrogen atoms in the reactants and 4 hydrogen atoms in the products. We have 2 oxygen atoms in the products and 2 oxygen atoms in the reactants, so the equation is balanced. As a reminder, we changed the subscripts to write the correct formula. Once we did that, we balanced the equation using coefficients only. Let's look at one more example. In question number 3, it says aluminum bromide plus chlorine yields aluminum chloride and bromine. At first, we might write the equation like this, but remember, we're going to check for diatomic elements. Both chlorine and bromine are diatomic, so when they are by themselves, they should have a subscript 2. Aluminum bromide and aluminum chloride are both ionic compounds, so we need to balance the charges. If we look at the periodic table, we can see that aluminum's charge is +3 and bromide's charge is -1. To make the charges add up to 0, we'll need 3 bromides. In the products, aluminum's charge is still +3 and chloride's charge is -1. Again, to make the charges add up to 0, we'll need 3 chlorides. I want to point out that chlorine and bromine are only diatomic when they're by themselves. When they're part of a compound, like aluminum bromide or aluminum chloride, the charges need to be balanced. If you have a molecular compound, the prefix will determine how many of an element there is. Once we have the correct formulas, we can balance the equation using coefficients. There are 3 bromines in the reactants and 2 bromines in the products. We want to make them the same, so we can think of the lowest common multiple, which in this case is 6. To get 6 bromines in the reactants, we'll need 2 aluminum bromides. And to get 6 bromines in the products, we'll need 3 bromines. There are 2 chlorines in the reactants and 3 chlorides in the products. Again, we can think of the lowest common multiple to get them to be the same. So in this case, it's 6. So we can have 3 chlorines in the reactants and 2 aluminum chlorides in the products, which gives us 6 chlorines. If we look at our aluminums, there are 2 aluminums in the reactants and 2 aluminums in the products. So this equation is balanced. You should work through the rest of the practice in your packet.